Hi, everybody. My name is Mary Ann Francis, and I'm your host today for the February edition of the Search Mastery Speaker Series, where we're exploring the foundations and practice of search, including skills education and literacy. And we're really excited today to have Jerry Thales and Pera with us to talk about supporting children's online information discovery. They have a lot of super interesting things to tell us. And I'll just to give you a little bit of a brief background on Jerry and Sole. So Jerry Thales is an associate professor in the computer science department at Boise State University in Boise, Idaho. He has designed technologies with and for children using participatory design methods for the last 19 years. As part of Jerry's research, he directs an intergenerational design team called Kids Team. The team consists of young children and adults who work together as partners to improve and design new technologies. He leads research in child adaptive search tools, security and privacy for children, and fitness technologies for children. He serves as the graduate coordinator in his department and is the International Interaction Design and Children's Steering Committee vice chair, and serves as an International Journal of Child-Computer Interaction editor, among other editorial and reviewing duties. Sole Pera is an associate professor in the computer science department at Boise State as well, where she co-directs the People and Information Research team. Sole's research strives to bring attention to how non-traditional users interact with systems that enable the completion of usual yet complex information access tasks. In the past 10 years, she has focused on children information retrieval, understanding how children interact with search and recommendation systems, and building the algorithm bridges needed to facilitate those interactions. Sole has also co-organized workshops intended to build community and promote awareness on the value of research about search and recommendation tools for children. And we're delighted to have you. I'll turn it over to Jerry and Sole. One last thing though, for the participants, you guys, if you have questions, you can go ahead and put them in the Q&A, or you can also use the chat. But if you use the chat, you really need to make sure that if you want everyone to see what you have to say, to make sure that you direct it to all participants, not just the speakers and moderators. So having said that, I'll turn it over to Jerry.
Great. Well, thank you very much for that kind introduction. It is a pleasure to be here. Obviously, I'm a graduate of University of Maryland. I'm very happy to be joining virtually again. And I'm happy to be talking about our research together. I'm here, as was mentioned, with Sole Pera, Dr. Sole Pera, who is one of the collaborators on this project, which is CAST, a child adaptive search tool. It's an NSF-funded project. And as you can see, the different co-investigators on this project are varied in our perspectives, right? So we have the HCI perspective, the information retrieval perspective, natural language, as well as the education perspective. And really, it's that combination of perspectives that's been so amazingly fruitful in this project. Today we're going to be highlighting the work, our collective work, but some amazing work from some of our students, Brody Downs and Garrett Allen. There are a lot of other undergraduate and graduate researchers that have been involved, but these graduate students were the leads on the research that we'll be presenting today, and we're very proud of their work. So, kids and search tools. Now, in order for emergent searchers to master search, they need to learn how to form and reform queries. They need to connect those queries to the results and understand those results. And systems need to support that learning and meet children where they are at. They need to meet and adapt to their specific and sometimes very individual needs. The research that we're going to present today is looking at children ages 6 to 12 as one of those communities of emergent searchers. And so this picture is intended to represent that human element. Now, in concert with that human element, right, there's a system that needs to be developed. And that system, sorry, I'm just making sure my Zoom is working here. That system allows someone to enter a query that goes into the computer, and the query is processed in some way. And then resources are retrieved based on their relevancy to that query. And not only are they retrieved, but they also need to be reordered or ranked in order to meet, hopefully, the intended need of the user. Now, with regards to search, right, and children, there are a lot of search engines that are available, right? And children often use the same search engines that adults do, Google, Yahoo, and Bing. Even though there are a lot of kid-friendly search engines out there. And yes, there are indeed a lot of them. This is just a small subset of those. And yes, we're adding one more, right, with CAST. But the idea behind CAST is we're trying to attack a lot of the different challenges, specific challenges that children face, right? And they're individual to children. While adults may face some of these, children face them in unique ways. And I'll just reiterate what was said earlier by Marianne. If you have questions, feel free to pause in between. Soleil's probably going to interrupt me and
without hesitation very soon.
add to things, which is great. So we're very informal in that regard. So feel free to ask questions as we're going along. So one of those challenges is selecting keywords, right? What is the keyword that we need to put into our query? And children face some unique challenges with regards to that some of which relate to some of these later bullet points. They also, sometimes get really short queries or get really, really long queries, question-like queries. Children face challenges with regards to spelling the words that they're trying to look for information on. Homonyms are a problem. The conceptual models that children have, right? A child may think fairy and even write fairy in a query, but maybe they're actually trying to communicate fantasy, right? So how do we adapt to meet those needs? And how do we allow them to reformulate the queries that they create? And then once those queries return some results, they need to navigate that search engine result page and identify what the quality of those results, and be able to see how well those results connect with their initial query, and then be able to understand what those resources that were retrieved actually are saying, right? These are all various challenges that children face. Today, we want to highlight some different research that we've done with regards to just 3 of these. And just to start the conversation, and we're happy to continue the conversation if anyone would like to afterwards, feel free to reach out. So I'm going to start off by talking a little bit about spelling. So as you can imagine, misspelling is going to lead to incorrect information being retrieved. And children misspell a lot as they're formulating their queries. Research has shown that. And children use different spelling strategies than adults do. Some of the common approaches that search engines use with regards to spelling are to just automatically correct it or provide some query reformulation aspects on the back end on the search engine result page, which sometimes just get ignored, right? Or often just get ignored by children. So the research I want to present today is looking at how we can support children in their spelling needs. We looked at a lot of different spell checkers that are out there and how they may support children, and ended up developing our own algorithm to identify spelling suggestions for kids, which I'll describe briefly. We also enhanced that by re-ranking those suggestions using some modeling, a lambda mart model, and then we compared that to other spell checkers and looked at how we can further enhance and allow and support children in selecting their intended word by using various cues. So this is just kind of a snapshot of what the spell checker might look like on CAST. So a child misspells bird, B-E-R-D, and then they're presented with a number of spelling suggestions. Now, our algorithm, which we call KidSpell, uses a phonetic base, right? So it transcribes the word that was typed to a phonetic representation. And actually, it also removes all of the vowel sounds. And then it does a mapping to words that are found in the age of acquisition database. So how children learn words over time. And the original algorithm, as you can see here, is it's a simple rule-based algorithm, which means that it is incredibly fast and efficient, right? And indeed, it is a lot faster and a lot more efficient than a lot of the algorithms that are out there, just in terms of, computational aspects. But we also have to evaluate it with regards to its efficacy in providing the correct word, right? The intended word. And so we evaluated it using some different data sets. You can see the data sets described here. Unfortunately, there aren't a lot of data sets that are out there for kids in a lot of things, for understandable reasons, right? There are a lot of privacy issues once we start sharing children's data. We need to be very careful about that. But we use some children's data that we were able to get from some essays, child essays. And so we have, as you can see, the misspelled word, the correct spelling word. We also have grade, and there, as well as an identified spelling proficiency level, which is there are different levels in terms of spelling proficiency. And then we also have actual queries, and we also wanted to compare it to adults misspellings as well, just to get a broad sense for how this algorithm may or may not serve adults as well. And here is just an overview of these results, right? So what you see here in this graph, they are the percentage that the word, the correctly spelled word, was in the first word. The K along the bottom there is if there's one word that is returned from our spelling suggestions, or 2 words, or 3, or 4, or 5 words, right? And as you can see, as we provide more spelling suggestions, indeed we should be increasing. You'll notice that Bing does not increase because they only provide up to 3 words in their public algorithm. And so KidSpell itself, which is that dotted purple line, just the simple rule-based, performs very well compared to some of these baselines. Bing, and then aSpell is also a broadly used algorithm that's used by many websites, actually. And then over here, you can also see the performance with regards to the set of queries. You can also think of this in terms of mean reciprocal rank. So in this, the higher is better, means it's closer to that top ranking okay? The correct spelled word is closer to the top ranking. And this all looks good. These graphs are nice, right? It illustrates that the algorithm can be effective in returning an intended word. But how does it actually play out when children are clicking on these words, right? And really, not surprisingly, right? Just as they do when they get a search engine result page, they often just click that first result because it's a computer. It should know what I mean, right? It should be able to know and retrieve the exact document that I need. Well, that happens here, right? They often select the first item. And so we looked at how we might assist them in choosing the actual intended word beyond just providing that list by using some additional cues. And so we looked at audio cues and visual cues as well as both in concert and looked at the relative advantages that they might have. So here's an example. Again, we saw this before the bird example, but here you can see that there's audio and a picture that is also displayed. Now, the audio, it's just a simple text-to-speech, right? We use a text-to-speech API and we play that. For the picture, we're using Google's image API, and we just get the first image that is returned, right? So this is very simple with regards to the cue. It's kind of hard to get a sense without playing it, so I'm gonna. I don't know if you can hear that audio, to be honest.
Very slowly, but yeah.
I probably didn't click the share audio in the share screen thing. That was my fault. But you get the idea. What's happening is there's a cue and it's reading each of those words as it's highlighting that picture. And our research then shows that indeed, as you can see over here, where they primarily clicked just that first one, trying it when no cues were given, we see there's some distribution here, and they start to more accurately select the word that they originally intended when they misspelled it. And we see that audio has a dramatic increase. Images, even though it's that simple algorithm of just getting that first picture, has some advantages as well. And then both together have some advantages. Indeed, it's significantly, statistically significant in terms of its difference from no cues, right? One of the challenges with regards to images, right, is that you're going to have things that can be more concretely identified versus something that's more abstract. And that is going to be one of the challenges. There are some benefits to a pictorial only, right? In that there's not that sound, right? You can imagine if you're in a classroom and there are 30 computers all playing sound, that might be a problem, right? Unless they each have headphones, which might also introduce other problems, right? We have also started to look at other ways that we can support the learning. So you can see that in our cues that we give, in our spelling suggestions, we also highlight the differences of the word that they spelled versus the word that we're suggesting. And the idea here is to help to bridge that learning gap so that they're able to identify and write that potentially correctly in the future. Additionally, you can see some grayed out words. The intent here, we haven't investigated this thoroughly yet, right? But the intent here is to try and help children, emergent searchers, understand that certain words are not helpful or even used in retrieving the resources that they're looking for, right? You can see these grayed out words, for example, are stop words, words that would be filtered out of a query generally before it is processed and resources are returned. So there are several different references on spelling, and I'm going to turn the time over to Soleil to talk a little bit about search results.
Let's see if I can manipulate the slides. Let's see if that works. So we talked about the formulation part, the query formulation, and the supporting that understanding of how to formulate right queries. I think that one of the drivers that we have in CAS has been that idea of search as learning, that the more children engage with the tool, the more they'll understand how they can be better searchers in the end, because we know that eventually they'll graduate to use Google. That's going to be the thing that they turn to. But until they get that proficiency to really take advantage, that has been the driving force behind kind of what we do. That, and as Sherry mentioned before, being able to have a cohesive loop that we take the ACI, the IR, the NLP, and the education, all of that cohesively to come up with these solutions, because spellings or query formulation or even navigation is not something that we just discovered. There has been a great deal of works that have been focused on that. So inspired on what we learned from those works and the premises that we have of teaching them how to search while they search, one of the other sides of what we're doing is focusing on how kids can effectively take advantage of the results that they get. We, and not just as adults, but as average search engine users, we're used to kind of like, we type something, we get the search engine kind of like result pages, we see snippets, we kind of scan through and we go to what we hope we need. And if we don't see it there, we right away get a new query. That's not how children approach search. And let's see, I did something else. Let's see if I can. No, I keep going to the participants. I'm doing something that is wrong. What about now?
Yeah, there we go.
There we go. Now you see my span. There we go. So to give you an example of what I mean, of how search engines might not be in producing these search engine result pages that children need, take a look at the query Sven. Back when, and if you don't know Sven, it's a character in the movie Frozen. And it really pops up on everything that I do regarding to like research with children. But it's a good example that quickly shows back when the movie first came out, and so the movie was already out, children were already familiar with Sven. But if you were to type Sven in Google, Google would not on purpose, but it would misunderstand that Sven, it would assume that you wanted to type 7 and that you only missed an E in your query. It would assume a completely different information need. And therefore, the first result we retrieved was the movie 7. So not only the missed opportunity for understanding the intent, but also something completely inappropriate to children. So that becomes a problem. Children were not necessarily going to chat, they were just going to click and they were not going to be happily surprised. But that's not the only problem. Think about searching, for example, Albert Einstein's last invention. An 11 or a 12-year-old searching for that for a school assignment. Well, the first result comes from answers.com. Are children going to really know what the source of the information they're getting? Are they going to know that it might be just someone typing an answer, kind of like a community building answer rather than a fact? And beyond that, will they be able to read and comprehend the information included in that result? And it turns out that more often than not, that is not the case. So those are just some of the examples that we aim to tackle with specifically CAS. How do we do it? Well, many questions to ask. The first one is, what is relevance for children? Relevance is a complex concept on its own. When you add a particular user group, it makes it more challenging to define. So we're looking here at trying to match information needs and skills. The information needs, we're going to hope that it's of children that are immersion searchers, but in terms of skills, well, research already says that the average readability level or text complexity level of search results at the top, it's of grade 10 or 11, which is way above what an 11-year-old or an average 11-year-old could read. So one of the first things we want to consider with CAS is this idea of readability and how do we handle that? The other question that is interesting is what is good for children? That's another challenging or complex concept. There are many perspectives or dimensions that impact what good is. And so we needed a place to start. And we're not here to judge what each parent or family or each school will decide to be good. We're going even before that, at the very beginning. We're saying, let's focus on a context and let's focus on finding appropriate resources, but going beyond safe search. And the reason we want to do that is already research has demonstrated that safe search is good at identifying, for example, nude pictures or lewd content, but it doesn't look at really violence. It doesn't look at bullying. It doesn't look at other topics that are just not really suited or well suited for 8 or 9-year-olds. And so without being too picky, we're starting with that, just saying, let's see if we can focus on a particular context, which is the classroom, and at least a very basic area of what we define, what we can automatically or algorithmically quantify as appropriate or inappropriate. And then last but not least, what do we know about how children search? We know that they look at the top result, like Terry said, and we know that we go one at a time in order. And so the best way to help them is to be able to really try to optimize results in a way that benefits them. So prioritize those results that are retrieved that will have the content, but that also are going to be most well suited for them. And we do that by adding to CAS a cost-sensitive kind of learning to run. So I'll dive into the technical part of that, but please, like we have been saying, feel free to interrupt us so that when you have questions, you don't get too bored about what we're saying. So we started with readability. There are hundreds, and that might be, I may be short, but there are like hundreds of readability formulas out there. I'm gonna need to come back, Jerry, because you're adding something into, no, you're fine. Let's see if
I was trying to open the chat. Just
there you go. That was a good idea, but now we're stuck in the classroom. Let's see if I can come back. There we go. Now I came back to readability.
Sorry about
so that. We started with, there are like hundreds of formulas that can be used to estimate readability. The issue with that is that, and Terry already gave you a surprise, but I'll get there. The issue with that is that there's no consensus of what are they actually measuring, what are they good for, because it's hard to compare and contrast. And so what we did is we started from the ground up. We picked Flesch-Kincaid, which is one of the most popular readability formulas. We picked Coleman Liao, that it's suited for digital text, and SPASH, which is suited for young audiences. And we tried to understand, well, these formulas, are they really effective or are they really accurate when estimating the readability level or the complexity level of content that is meant to be targeting children? And it turns out, if you see here, that they're not. The error rate, these are error rates, and the error rates are appalling. We're talking about 7 or 5 or more grades above what they should be predicting on material that is for young users. And so we thought we would have to do better. The best one of all these formulas looked to be for the audience SPASH. But then we said, well, SPASH was last updated in the 40s with vocabulary that it was considered simple or child-friendly in the 1940s. So we took advantage of the age of acquisition data set that has a list of words that children should know at different ages. And we take advantage of the Requick data set that has a set of keywords that children are familiar with because of their engagement with websites. And when we, just by simply adding to the 1994 this vocabulary, these two lists of words, we see that consistently the error rate of what we call the SPASH-Allen decreases, and it's actually more stable for lower grades. So that's the metric that now we're using for CAS to estimate in readability. So that was one of the problems, but we discussed many more. If I can move to the classroom setting. We thought that this share of the screen was going to be a good idea. We need to practice more.
I'm sorry, I'm trying to look at the question and answer now.
Which makes sense.
Is this the slide you want to be on?
No, I want the previous one.
There you go.
There we go. That is exactly what I want. So now that we know that we can identify material that children can read, the next question is, well, can we identify material that would be suitable for the classroom? We decided to define suitable for the classroom as materials that align with the topics covered in the K-12 curriculum. So for this one, we took advantage of, we wanted to be able to be fast and efficient, because if the search process is going to take forever, it might be great, but children are not going to have the patience. We discovered that a long time ago with our first work on query suggestions. The suggestions were great, but they took forever and children were like, nope, not worth it. So this time around, we prioritize efficiency. And so for that, we look at only at the snippets and the URLs. And we take information from the snippets, we take information from the URLs, and we take advantage of PIRET that is fine-tuned to the classroom context in order to be able to predict or estimate the likelihood that a particular resource it's aligned with the educational context, the K-12 curriculum. If you see on this table below, we did an in-depth analysis, but the highlights or that I thought it was worth sharing is that the importance of looking at both the URLs, which is the U, and the snippet, not just one or the others. There are going to be URLs that are very well formed, and they're going to have keywords that are going to be perfect hints of an educational content, but there are going to be other resources that is just a bunch of numbers, that URLs that are not going to have that content. And in that case, the snippet, or being able to take advantage of even the few words, including the snippet, it's what's going to be fundamental to really get to know the content of a particular resource. So now we have the readability, we have the alignment with the classroom. I mentioned that we also work on this idea of appropriateness for the classroom, which is a very basic random forest, but we look at different signals or different data points that align with not only inappropriateness in terms of like violence or looped content or vocabulary, but also looks into bullying and other topics. And so when we have all that, we're ready to build this idea of supporting the ranking for the classroom. Let's see. And maybe, Jerry, you want to move it to the next one? Because I tried and it wants to stay in the classroom. Perfect. So how we accomplish that is by taking advantage of a multi-perspective, or what we call multi-perspective re-ranking strategy. Why re-ranking? Because we're not saying, and I think that we mentioned that at the very beginning, we're not saying Google is bad or Bing is bad. No, all these commercial search engines have a richness and a volume and a capacity to store resources that it's not something that we could do on our end. But what we could do is take advantage via their search APIs and giving, of course, proper attribution, but take advantage of the resources that they would retrieve in response of a query, and then reorganize to prioritize the ones that children would or should gravitate towards to, or the ones that would help them complete that idea of an information need. So for that, we took, like I said, a cost-sensitive approach that would look at readability and educational alignment as the reward part of the ranking, and then as the objectional side as the risk, and try to establish a balance, because there's no such thing as something perfect. A resource could be suitable in readability for the child, so the child can understand it, but it might not be educational. It might be educational, but also be for grad school. Or objectionable, it's not a yes or no type of thing, depending on the grade, depending on the understanding of the child, depending on the context in which some terms are used, they might be more or less acceptable. There are things that are going to be like 100% a no, but there are great areas. And so with this cost-sensitive strategy, we try to balance exactly that. And so for that, we train a learning to rank, which is list-wise. So we look at, given a query and possible resources, what would be the optimal ranking when presented with all of set of resources. And that's how we predict a relevance score or a ranking score that allow us to reorganize the resources retrieved and then present that to kids. Let's see. There we go. So this is internally what it looks like. We take the resources that we get. In our case right now, we're running it. We keep switching, but I'm pretty sure it's Bing. But Cherry, correct me if we're wrong. I think that right now we had Bing under the hood when we did this experiment. So we get the results, and then we create for each for each snippet and URL, we create we estimate its educational value, its readability score, and its objectivity score. And then we create these risk and reward modules that then go past the balance module in that optimization for the learning to rank in order to be able to generate this new result. And we call that, well, in a paper that hopefully soon our already graduated master student will send it ready for review. It's on the last stages, but we call it Reader Rank. But for us, it's going to be the ranker that enables that bridge of supporting children navigating more comfortably search results to find the information that they need. So with every research, we have to make sure that it was not only doing what we believe or what we wanted it to do, but it was also living up to expectations. So on this table right here, what we call an ablation analysis, you'll see that we not only compare the final version of our algorithm, but alternative strategies where we say, well, what happens if we don't use the educational value? What happens if we don't use the readability? How can that impact the overall functionality? And then it was good that we compare with what it's potentially the state of the art. There's not that many works that work on the space that we're working on. And so it was that makes it a challenge to compare and contrast and really put it into context. And so we decided that for sure we wanted Landamar as the baseline. Landamar is a very well-known ranking algorithm. And so we wanted to see how it fared when compared to ADA rank, which is what we chose. And then course, it's more of a weight-based strategy. It looks at readability based on Flesch Kincaid. And as you know, we found some problems with that. And it looks at also objectionable content, but it's not as comprehensive on what is determined or what is just to be objectionable. And so that gave us an idea of how Reader Rank actually was performing the task it was meant to perform. And so, like before, plenty of papers. One of them we're going to be, or one of our students will be presented actually tomorrow in a workshop, and then in a couple of weeks at a main conference. So we're very much looking forward for feedback from there. But now the floor is back to you, Jerry. But you can drive and I'll interrupt as needed.
Yeah, please feel free to. So we took a deep dive into a few different areas here, but the overall goal here is to adapt systems to support children's search needs and provide mechanisms or scaffolding for their learning along the way, learning how to search. That involves that human element as well as that system side element. Now, we've also done some other interesting work in trying to look at different contexts of use. So, for example, we have developed some curriculum standard aligned lessons that provide children opportunities to search and find information and go through this process in a live search environment using CAST.
And we should add that this was kind of CAST opportunity to, even though we're driven by research, this was an opportunity to kind of support the community during COVID, when teachers were just naturally taking advantage of conducting assignments related to inquiry. So we really partner with, well, our co-PI, Dr. Wright, but also her students, and they created these lessons. And then we just kind of like embedded it in CAST so that children could take advantage of CAST to do safe searches that then they could use to learn information and put it back into classroom assignments.
Yeah, excellent. Along that educational side, right? Oftentimes teachers will allow children to search for various information and find that information online, but they really don't know what it is they're searching for, right? But we have developed a portal where they could take, for example, CAST into a classroom, and the teacher could get an overview of all the different queries that their students are making, and the kinds of results if they really wanted to, but they can also use that as a mechanism to help teach and direct and guide them as they're searching. In addition, because we have that spelling information, we can provide that information as well to teachers, right? What are the children having difficulties spelling, for example? And there are some different settings that teachers potentially could make in there. But all of this is to say is we're really trying to support children as they search in adaptive ways. And we have a lot more work that we are currently doing and looking forward to do with regards to readability, as well as customization of results. And we're happy to have been here today, and we'd like to answer questions that you have.
Thank you so much. That's super, super interesting. We have one question in the Q&A, and people feel free either to put the, additional questions there or in the chat, or you may, if your question's more complex enough, we can give you the floor and you can clarify. But I'll just start the discussion with a question that I have listening to you, which is what are examples of children's search needs? Like why do they need to search, and what types of questions can't they get answered in any other way?
Well, I would say they can obviously get questions answered in a lot of different ways.
Yeah.
Right. There's no reason that they couldn't go ask their parents or guardians, right, or their teacher, or go to their library, or right. There are a lot of different resources that are available. We do know that children are utilizing the internet at a large rate, right? And so given that they are using that as a resource, how can we provide or create that resource in such a way that it supports their kinds of needs, right? That
yeah,
it meets them where they're at.
Yeah, it's so interesting. So is it that they're imitating their parents or their brothers and sisters, or?
I think that
I would say
there's
it's
a nice.
Yeah, go ahead.
No, I was going to say that there is a nice book that I keep kind of referencing back to in things like this, which is the one that describes the Google generation, and they talk about these young little kids. They don't really know that they're engaging with a search engine. They're just mimicking that behavior. Like they know they type something and they get something. The quality of what they type and the quality of what they get, and they don't know. But even at the very beginning, it's like that magic box that you know that something goes in and they get something out. And so that, and now with all the screen time that they have, that now very young with a couple of like touch things, you can already get access to games and things like that. Children are just used to it. And so for them, that's their portal. They know that they go there and they get something. And they don't move past that idea of like judging how good, how bad, how useful it is for the context that they needed. That is not happening just yet, but they know that they naturally turn to that. And so
and I'd say it goes beyond mimicking as well, right? They're formally instructed by teachers to look for things as well, right? And so I mean, they're obviously going to, well, not that all children follow their teachers, but a lot of them do. Right? And so
so it's incorporated into the academic environment.
Correct.
This idea of inquiry assignments, that it used to be that they gave you a homework and then you went and you have like the textbook for the classroom, and that's what you would do it. Now it's just much more common to have that embedded in like on digital resources. And from there, it's a very short jump to, well, digital resources that is curated to the search engine where you would just turn to find more about a topic. And so it's just, I think it's just embedded. Sadly, it's not thought about. So this idea of search literacy, it's very rarely taught. So children just use it, but they don't know how to use it well. And so I think it goes hand in hand. There's a lot we can do algorithmically, and we're trying with interfaces and the backend to support. But in the end, the key is that understanding what's going on so that they can have that self-efficacy of taking advantage of these tools.
Yeah, oh, super interesting. Okay, there is a question in the Q&A that I'll just read out to you guys. So when working with children, for example, kids team meetings, what kinds of methods do you use to help children articulate their needs and wants? As we know, young students don't have the vocabulary to adequately verbalize what their needs are.
Yeah, so you bring up a great point. We use a lot of participatory design methods, and there are even within participatory design methods, there's a wide range. Primarily, I follow a cooperative inquiry type approach where we work with children a lot, and it's over an extended amount of time. It's a little bit different than like a drop-in participatory design session where in some cases it's a lot harder to get to some of that authenticity, right? But because of that development of a relationship over time, that authenticity is a little bit more accessible, in my opinion, in my experience, with working with kids teams for the last 19 years. And so we use a lot of different techniques, some low-tech prototyping, sticky note evaluations. We do some this or that and other evaluation type techniques as well. I didn't talk too much about how we actually developed some of those cues, right? We just jumped straight to the actual data and the comparison, but there indeed were a lot of design sessions involved in coming up with how we might convey the information of misspelling and the different cues. We developed those iteratively through our design sessions with kids team. I don't know if that fully addresses your question, Valerie. If you have a follow-on question, I'd be happy to answer that as well.
And I would like add, because there is always that trade-off between what they want, what they need. And I think that in kids team, Cherry has really managed to like guide our students and the kids group in gathering all that. But the other thing that we do is we actually also take a look at, for example, query logs, things that they might not articulate as they want that, or they're struggling. But then when we look at the type of queries they do, of the type of items they click, then we start kind of striking that balance between what they say and what they do. And that's how we find that sweet spot to say, well, let's start here. That seems to be the meeting point.
We have, Valerie says that you did answer it, so thank you. And then from Cheryl Knott, we have a question. And she says, I'm sorry if I missed this, are teachers involved in your participatory design approach? If they are, do you find children and teachers have very different ideas about search? And then this is related to a question that I have as well, which is, are you noting just the differences between children and adult search behaviors? And if you are there, are there examples of that?
Yeah. So to the question that's in the Q&A, are teachers involved? So yes and no. we have, so for example, the teacher portal that I showed at the end, we indeed, we came up with some initial mock-ups and we iterated with some teachers with regards to how that might work and how that might look. And so we have been working with teachers in that regard. We also, so a lot of the data that we get, one of our co-investigators is in the education department, as you see there. But as part of that, she also teaches teachers how to teach, right? In literacy programs and education. And so we incorporate some of that feedback, but they have, beyond our co-investigator being involved in those design sessions, we haven't invited a lot of other teachers directly to be involved in the same design sessions as kids, if that's your question.
As a follow-up though to what Cherry was asking about teachers and children having different ideas, we're more focused on the immersion searchers, so we're still trying to understand the children. But there was late last year, and I can dig it out and share it if you want, an article from a group working with children and search in New Zealand, that they actually tried to model what the system technically should do that in response to the gaps identified in the literature, what children see the process was, and then what teachers expected the process. And there was not a lot of overlap. And so that was a very interesting article of what teachers thought that children were doing and how they were taking advantage, and then what children were doing something different. And the system was not supporting 100% either, because it was not designed for them. And so we cannot blame the system that wasn't designed for them because it's not supporting. But it was a very interesting article to see that in paper, because we have our anecdotes of how children search and the teachers and the wants and the needs, but that one was very good to see it in very contrasting images. So
super interesting. Let's see, we have another. Cheryl says, thank you. This is very important work that you're doing. Let me just ask the participants if there are other questions that you have for Jerry and Sole. We'll give it another minute or two, or you can raise your hand if you have something, or put it in the chat.
And we're both good at answering emails. And so sometimes it's a lot of info and then things pop up. So we're always happy to chat about CAS.
Yeah, if not, then I'll just say, I have another slide, but I think I won't put it up, but I'll just go ahead and first of all, thank Jerry and Sole for being here today. This was really, really an interesting talk. But I have a whole other list of questions that I won't share right now, but maybe another time. And I want to let everybody know that we have another talk on March 17th. It will be Jason Boyd Graber from the University of Maryland, who's doing a lot of interesting work. There'll be information about that distributed later so that you can register. This talk has been recorded and it will be up on our on the Search Mastery Interest Group website in probably in the next few days. So if people want to revisit it, it will be available for you there. So thank you very much to our guests, and we'll see everybody next time.
Thank you,
everyone.
Bye. Thank you.